So the next topic is absolute and relative measures of dispersion. So all the measures that we have discussed so far are absolute measures of dispersion. So they calculate a value which at time it is difficult to interpret. So that is why these absolute measures of dispersion faces some limitations or problems. So absolute measures sometimes give misleading ideas. They give misleading ideas about the extent of variation, especially when the averages they differ significantly. When the averages is different from each other to a large extent, then it gives a misleading ideas. So there is one limitation of absolute measures of dispersion. The second thing is, another weakness of these absolute measures is that they give the answer in the units in which the original values are expressed. Unit. That is why consequently, if the values are expressed in kilometers, the dispersion will also be in kilometers. However, if the same values are expressed in meters, and absolute measures will give the answer in meters, and the value of dispersion will appear to be 1000 times. That is why when they give the answer in units, it is facing that limitation. And when the averages are different from each other to a large extent, they give a misleading ideas. So to overcome all these problems or all these limitations, relative measures of dispersion can be used. So instead of absolute measures of dispersion, we can use relative measures of dispersion. Thus, for range, quartile deviation, mean deviation, and standard deviation, we can use the relative measures of dispersion. So for range, there is a coefficient of range which is calculated as follows. So coefficient of range is equal to L minus S divided by L plus S, where L is the largest value and S is the smallest value. Similarly, for quartile deviation, it is coefficient of quartile deviation which is given by Q3 minus Q1 divided by Q3 plus Q1, whereas Q3 is the third quartile and Q1 is the first quartile. And for mean deviation, it is coefficient of mean deviation which is given by MD whole bracket x bar divided by x, or MD in the bracket median divided by median. That is coefficient of median. Thus, if mean deviation is calculated on the basis of the mean, it is divided by the mean. And if median is used to calculate mean deviation, it is divided by the median. So that is in case of mean deviation. For standard deviation, the relative measures is called coefficient of variation. Given by coefficient of variation is standard deviation divided by arithmetic mean into 100. So it is usually expressed in percentage terms, and it is most commonly used relative measures of dispersion. Since relative measures are free from the units in which the values have been expressed, they can be compared even across different groups having different units of measurement, which is not possible in case of absolute measures of dispersion. So the last topic that is left with us is the Lorentz curve. So the measures of dispersion discussed so far, they only give a numerical value of dispersion. So a graphical measure called a Lorentz curve is available for estimating inequalities in distribution. So we shall discuss how to construct Lorentz curve. So Lorentz curve is nothing but a graphical measure to calculate or to measure dispersion, because all the above measures that we have discussed is giving a numerical value of dispersion, but a graphical representation or a graphical measure used to measure this dispersion is called the Lorentz curve. So let us try to know all the steps that is involved to construct a Lorentz curve.